think of there as just being a positive 1 outside of here. So that positive 1 distributes to the negative 2x to give us negative 2x, and then the positive 1 distributes to the negative 6 to give us, well, negative 6. All right, let's simplify. 3x minus 2x is positive x, so you can just write 1x or x, minus 6 equals negative 10. Now this is just a one-step equation. We will add 6 to both sides. By adding 6, those cancel, giving us x equals negative 4. All right. Again, we have x, but we don't know y. So what we'll do is we'll take that x and we'll dump it into one of our original equations. I'm going to dump it into this top equation right here. So y equals negative 2 times x, which we just found out to be negative 4, minus 6. That gives us y equals 8 minus 6. Finally, y equals 2. There you have it. That is the solution to our system. Let's get a move on down here. All right, let's graph these problems. We should be well practiced in graphing. So remember, our equations all represent linear equation, or all represent lines. So let's graph these lines. These probably will not be straight lines. I'm warning you ahead of time. So let's look at this first equation. We have a slope of 3 and a y-intercept of negative 2. So there's our y-intercept of negative 2, and our slope of 3 means up 3 over 1, up 3 over 1, up 3 over 1. So there's our line. Oh goodness, terrible line, terrible line. And now let's graph our second equation. This negative x means we really have a slope of negative 1 and a y-intercept of positive 2. So I'll go up 2, 1, 2, and use our negative slope. Down 1 over 1, down 1 over 1, down 1 over 1, and so forth. And you can clearly see that there's our intersection, which is at 1, comma 1. That's the solution to the system, 1, comma 1. Okay, number 8. Now remember, one of the criteria for graphing a system of equations is that our equations need to be in a ready-to-graph form, meaning y is isolated. Is the y up here isolated? No, of course not, because it's not by itself. Isolated means to be by yourself, to be completely alone. This y is alone on the side of the equation. This y is not. We must get this y by itself. So I will rewrite my equation. Okay, I see that this negative 8x is in our way over here, so I will add 8x to that side. I'll add 8x to that side, so those cancel, leaving us with 2y equals 10 plus 8x. I will divide by 2 now to get rid of that 2. Cancel out, giving us y equals 5 plus 4x. So there's our b right here. Here's our m right here. Remember, the m is always the number in front of the x. There's our x-axis, our y-axis. So now we have this equation is ready to graph, and finally this equation is ready to graph. Something cool is about to happen here. So let's graph this one first. Y-intercept is negative 2, slope is 4. Okay, there you go. There's our line. It's a terrible line. And let's do this equation. Our b is 5, 1, 2, 3, 4, 5. And our slope here is 4. Up 4 over 1, 4 over 1, 4 over 1. These lines, believe it or not, actually you must believe it, will never intersect because they're parallel. How can you tell they're parallel? Because both of their slopes are equal to each other. The slope here is 4, the slope here is 4. Therefore, you see that it's the 4 in front of the x. Therefore, these lines never intersect. Therefore, there is no solution. No solution. Neat problem. Let's take a look at the next one. Solve it using a graphing calculator. If I have time, I will come back and do that one. Let's look at number 10, because I don't have my Yeah, I don't have my graphing calculator loaded up on my operating system here. So let's look at number 10. Solve the systems using any method you prefer. Well, here, what I'm going to do is I'm going to choose the easiest method. Okay, what do I notice? Essentially, any method is code for either graphing, we can graph it, we can use elimination, or we can use substitution. Alright, well, let's look at that problem. What is it set up? What is it set up to do? Is it set up to graph? Well, no, not really. This y is not isolated. Is it set up to eliminate? No, because the y term is above the x term, the x is above the y. None of the terms are like, meaning we'd have to do some manipulation to get this top equation to perfectly, to get all the terms, to get the x terms lined up, the y terms vertically lined up, and then the constants vertically lined up. How about substitution? Is anything isolated? Yes, this y is isolated. We can easily take this value here, this expression, y equals negative 6x minus 2, and dump it into this y right there. So let's start rewriting that equation, the second equation. 12x plus 2y, but guess what? Y equals negative 6x minus 2, negative 6x minus 2, and notice that I'm writing it in parentheses, equals negative 6. Let's make a quick little distribution down here and rewrite our expression. 12x minus 2 times negative 6x is negative 12x. 2 times negative 2 is negative 4, equals negative 6. 12x minus 12x is 0, minus 4 equals negative 6. Finally, that leaves us with negative 4 equals negative 6. Does negative 4 equal negative 6? No. So, guess what you can say? There is no solution. No solution. Meaning these lines are just like number 8. These lines are parallel lines. I believe these lines both have a slope of negative 6, if I'm not mistaken. Yes, they do. They both have a slope of negative 6. Okay, let's take a look at number 11. Okay, is it set up to graph? No, both y's are not isolated. Is it set up to substitute? No, neither y is isolated, so this would be a difficult problem to substitute. But is it set up for elimination? Yeah, it's set up for elimination, because the x terms, y terms, and the constant terms are all lined up. They're both in standard form. Okay, let's figure out what we need to do here for a substitution. If we wanted to substitute, or if we wanted to eliminate, I said substitution, I meant elimination. If we wanted to eliminate the y term here, we need to figure out what a common factor between 15 and 10 is. So let's start counting by tens. 10, 20, 30, 30. 10 and 15 both go into 30. 15 times 3 is 30, and, I'm sorry, that's incorrect. 15 times 2 is 30, and 10 times 3 is 30. So we know that what we can do is we can multiply one equation by 3 and the other equation by negative 2, and I'll show you that. So what we need to do is we'll multiply this equation. I'll multiply it by negative 2, and then I'll multiply this equation by 3. And watch what happens. Negative 2 times 9x is negative 18x. Negative 2 times negative 15y is positive 30y. And negative 2 times 24 is negative 48. And now let's do that same process to the bottom one. 3 times 6x is 18x. 3 times negative 10y is negative 30y. And 3 times 16 is, what is that? What is 3 times 16? 42? Boy, I'm looking like a huge idiot right now. Yeah, 42. No, 48. 48. It's 48. So, watch what happens here. Oh, wow, something magical happens. Negative 18x plus 18x is 0. 30y minus 30y is 0. negative 48 plus 48 is 0.